Greetings to all. In today's session, we are going to discuss about the intermediate chemistry. It will be helpful for your international entrance or any competitive exam you are seriously preparing for. National level JE advanced and JE mains examination to enter into IIT stream and also NIT stream of technical education. NEET chemistry for medical entrance across the India. In addition, Telangana and Andhra Pradesh MCET examination for engineering stream. If you are aspiring for any government examination where you can find general studies as the common paper, where the content you will get will be a science. So in that, the questions what we are discussing is very much fetching. Let's enter into our today's session. Question number 1 is IUPAC nomenclature related question. Explain the name of following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. As per the IUPAC, you need to assign the name for given organic compounds. All these are the benzene and having substituents at different positions. Here, numbering is provided to you 1 to 1, 2, 3, 4, 5, 6. 6-member ring it will be either first, second position got substituted, first, third position, first, fourth position got substituted. In this case, you have to assign the name for these compounds. In order to name them, let me mention the position 1, 2. What are there? Methyl. 1, 2 dimethyl benzene. You can assign IUPAC name 1, 2 dimethyl benzene. And the second will be 1, 3 dimethyl benzene. And third one will be 1, 4 dimethyl benzene. And they are generally known as, so this is the name, this is the compound with the 2 methyl on benzene called xylene. And what xylene? 1, 2 positions are called ortho, so that we can say orthoxylene. So mostly the compound with the 2 methyl is called xylene and 1, 2 position ortho, so that orthoxylene name will be. And 1, 3 called metaxylene, paraxylene it will be. This is a kind of naming in accordance with the IUPAC protocol, right? Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. Which equation shows an oxidation process? Oxidation can be explained in the various domains. Various definitions are provided. In terms of oxygen, addition of oxygen is called oxidation. In terms of hydrogen, removal of hydrogen is called oxidation. In terms of oxidation number, increasing the oxidation number is called oxidation. In terms of electrons, release of electrons called oxidation. This is the way so many kind of definitions you can find for oxidation process. In terms of oxygen addition you are seeing here, so that we can clearly say this is a kind of combustion process. Whenever carbon added with oxygen, carbon dioxide formed, it is simply known as oxidation process. If you see compound number 2, calcium carbonate converted into calcium oxide, where 3 oxygens converted into 1 oxygen, so that it is not the kind of oxidation. Here, calcium oxide converted into calcium chloride, oxide to chloride, so that it is not all. It is also not the oxidation process. Here, N2O4 converted into NO2, so that it is also not the oxidation. Not nowhere you can find increase in the number of oxygens except in the compound number 1. In the equation 1, you can see carbon added with oxygen, so that oxidation. So that here explanation is provided. Gain of oxygen always regarded as any metal. Gaining oxygen, metal or non-metal it might be. So gaining oxygen is the kind of oxidation process. Whenever hydrogen removed, here HCl called hydrochloric acid converted into chlorine gas. Here also the process called oxidation. So that oxidation is the process where oxygen got added. So for question number 2, option number A is the correct answer. Move on to question number 3. Question number 3 is collected from JEE Advanced 2020 question paper, and paper 2 it will be. Fine. So here unknown compound with the molecular formula C9H12 is provided, which is designated as P. And this bond with multiple reactions like this in left direction, right direction, bottom direction, these many possible reactions, and some extent of products will be generated. Let's see. P upon treating with the NaNH2, so the might, and C6H5COCH3, this is called what? Uh, Acetophenone, and another hydrolysis under acidic conditions. There is a compound called optically active or will be formed which is optically active. And the same C9H12 can be treated with platinum hydrogen. This is a kind of reduction so that a known compound will be formed with the cyclohexane with the side chain of CH2, CH2, CH3, right? And this unknown C9H12 will be treated with reagent X. X is unknown to you. And potassium permanganate will be added, sulfuric acid will be added, heating is required. C8H12O6 will be formed, and again it is optically active. These many possible reactions we have to get, so that what is the P? If you identify P, so that we will move forward in order to reach out the products. In order to get that one, what kind of answers are correct? B is correct, C is correct. So that you can find the tick mark over here. X is palladium carbon quinoline hydrogen. X is here the reducing agent will be added, so that from this data it is clear that whatever C9H12 you are taking, obviously it will be unsaturated, because in order to get saturated compound, what will be the formula? C9 what CnH2n plus 2 will be there for saturated compounds. Obviously C9H12 indicates what? There is a unsaturation. Whenever unsaturation is there, there is a addition of such a hydrogen in the presence of palladium carbon, so that you will get certain extent of saturation over there. So that kind of possibility you can find. We will see. And one more correct answer will be P is the kind of P means what? Starting material what required. That P will be double bonded and triple bonded like this. This is called a endocyclic double bond, and this is called a exocyclic triple bond. Endo means within the ring, exo means outside of the ring if triple bond is there. Okay, so this is called P. Let's see how can we achieve all the possible reactions. Whenever P is like this, okay, cyclohexene and containing terminal triple bond, hydrogen, palladium, carbon. What is the role of this one? Reducing agent. Whenever reducing agent is added, and palladium carbon is a controlled reducing agent, not complete. We are not supposed to go for complete reduction. Complete reduction gives rise to this bond reduction, this bond reduction as well. But what we are doing, only triple bond converted into double bond. Double bond is unaffected. This is the called a mild reduction. Fine. Followed by potassium permanganate under acidified conditions if added. What it will do? Wherever double bond is there, there you can go for carboxylation. So here the carboxylation, here the carboxylic acid will be possible at the terminal carbon atom. And here is the ring opening is possible, and this carbon is also converted into carboxylic acid. This is the way you can go for what? Go for series of reactions in one direction. And another sodium liquid ammonia. They mentioned NaNH2 here. NaNH2 mentioned. In order to achieve NaNH2, we have to add sodium in liquid ammonia. Whenever sodium in liquid ammonia is added, what it will do? That used to convert triple bond into double bond over here. The formed double bond further treated with acetophenone. The second reagent added will be acetophenone. Acetophenone, if added, acetophenone is the kind of reagent where you can find electrophilicity around this carbon atom, so that whatever this high electron density on the terminal carbon will be attached over there, so that we will get pH CH3OH like this. Addition product will be generated. Simply we can say nucleophilic addition product it will be. And further protonation upon heating, simply you have to remove. Here we have CH3, one hydrogen, one OH. If dehydration, that means removal of water, here also you can find one double bond like this. This double bond will be generated. That is the product R. R will be generated, in this direction. And platinum hydrogen. Platinum hydrogen is the powerful reducing agent wherever double bond is there, wherever triple bond is there, entirely converted into what? Saturated one. So complete reduction gives rise to this is the product, complete reduction product. And Q we already got. Q is the tricarboxylic acid compound you can achieve. This is the way we can go for the series of reactions. If we are aware about the reagent and its specific activity, then only it is possible to achieve what product in what direction, right? For question number 3, we have multiple answers. One is X reagent taken will be palladium carbon in, and the reduction is possible. Quinoline is a solvent over here. And in case of option number C, starting material is mentioned over there where we have cyclohexene and with the CH2, CH triple bond, CH alkyne, terminal alkyne will be there. These two are the correct answers for the given question. And this is about the series of reactions possible in order to explain the complete question. Move on to question number 4. It is a kind of analytical chemistry part, and moreover volumetry part. It will be a solution of 0.1 molar weak base. B for base it will be is titrated against a 0.1 molar strong acid. Ha denotes a strong acid over here. The variation of the pH of the solution of the volume of Ha added is shown in the graph over here. What is the pKb value of the base? pKb value to be determined. Okay, the neutralization reaction is B for base plus Ha plus strong acid gives rise to BH plus and A minus. This is the neutralization reaction. Whenever volume of HA is added from the burette, the pH of the solution is pH of the solution is changing this way. Being starting material is a weak base, you can start the reaction from this zero coordinate reaction will be started over here. So whenever HA is added, slowly reaction is inclining towards downward. And at particular instance, this is the most important part we can notice. So at this particular instance, though you're adding volume of HA, there is no change in the pH. Here you can clearly notice from this to this region, pH will not be varied. Wherever you are noticing the constant pH is said to be buffer action. This is called buffer action. That is an important key position what required for our problem solving method. At a 3 ml of pH of the solution is 11. So this is only the key part where you can go for the problem solving. So in between 2 and 4, you can find a 3. So this 3, at this point 3, so the pH of the solution is said to be 11 because in between 10 and 12, you can find 11. They are saying the same point. At 3 ml of addition, pH must be 11. Okay, so here neutralization reaction is known to you, already mentioned in the problem. B plus HA gives rise to BH plus and A minus. This is the way H plus is added to base so that neutral compound will be generated. Whenever 3 ml of 3 ml is added, at the 3 ml point, buffer action is shown. We clearly noticed whenever 3 ml of this HA is added, at this instance we are not getting any change in the pH of the solution. It remains constant till 6 ml. So that this is called a buffer action point. So that POH is equal to negative logarithm of OH minus concentration is given by pKb. The pKb is equal to 3. So this 3 indicates what the given solution is said to be basic buffer. Buffer used to maintain the constant pH, and being it is obtained at pH 11, so that we can clearly say it is the basic buffer solution. So that pKb value is indicated as 3. The answer will be 3. For question number 4, answer will be 3. This is a kind of question you can find in analytical chemistry, volumetry part, and as well as chemical equilibrium part of intermediate chemistry. Move on to question number 5. Question number 5 is collected from Telangana Gurukulam Degree College Lecturer Entrance Examination, where you can find the organic compound and suitable reagents are added so that a product is required to be identified. The product formed in the following reaction is, this is the kind of system with the benzene ring, here another benzene, both are connected with the sulfone functional group. And here methyl, hydroxy, nitro, nitro are located. Okay, it is the kind of aromatic system connected with the sulfone. So when you are treating with strong base sodium methoxide is known to be strong base and further hydrolysis under acidified conditions. Upon these conditions, what product you are expecting? Very simple to identify. From the options, we can clearly eliminate the uh, what wrong answers first. So here you can clearly find NO2, NO2, CH3OH. And the sulfone is there. Sodium methoxide is a strong base over here. What it will do, we will see. Okay. So here NO2, NO2 is there, CH3 is there. Ether linkage will be definitely produced, that's perfect. But here one of the functional group is missing, so that you can cancel out this one. In this compound, one of the nitro group got removed. This is also wrong. And in this compound, nitro is there. Both nitro on two different rings. How can you shift two nitro onto two different rings? So that you can cancel out this part as well. So only the thing required is option number 1, where NO2, NO2 remain same positions. So wherever SO2 is there, so here it will be following free radical mechanism. Whenever SO2 is removed, you can find out here free radicals over there, and in the presence of sodium methoxide, they can be treated. Here OCH3 will be generated. Further, both are linked with the ether linkage, and whatever SO2 is removed, not completely discarded from the system, rather being it is the electrophile. SO2 is the electrophile for sulfonation, right? So that it used to attach at OH position called substitution reaction, and OH can be removed, SO2 will be added. Whenever SO2 is added, further hydrolysis we are doing, no? So that it finally converted into sulfonic acid. This is the way OH totally converted into SO3H called sulfonic acid. And this will be the expected product for question number 5. You can clearly notice for question number 5, option number 1 is the correct answer. Move on to question number 6, last question of the session. Here, the benzene ring with NH2 and COOH, this is called anthranilic acid. Orthoaminobenzoic acid is the IUPAC name. Anthranilic acid is the common name for the system, and it is treated with C5H11ONO. ONO is called nitrito, and here C5H11 is the kind of organic chain it will be. This is a compound when added, there is a kind of decarboxylation followed by deamination gives rise to the benzene. Benzene is the typical intermediate in the organic chemistry for the various compound synthesis. H plus and THF will be added. H plus is the kind of electrophile added on the benzene, and subsequently methanol will be added, so that we will get this product called OCH3 benzene. Methoxybenzene is called anisole, right? So what they are asking is, what intermediate will facilitate this kind of series of reactions? That will be benzene intermediate. The reaction will be facilitated by benzene intermediate. We will see detailed mechanism for the system. Whenever antranilic acid is there, by means of diazotization, so that decarboxylation gives rise to benzene, this is a common mechanism. But within the problem, they mentioned that antranilic acid is treated with C5H11ONO. ONO is again nitrate only, so that this nitrito will facilitate this decarboxylation followed by deamination, gives rise to benzene like this, and whatever compound is there that turned into OH, nitrogen is removed, carbon dioxide removed, water is also removed. This benzene intermediate further treated with H plus, no? H plus when added, electrons will be polarized like this, and you can get H plus addition over there, and carbene will be generated. That carbene will be attached with the methanol, so that we will get a methoxy. Lone pair of electrons and the oxygen will be attached at this negative charge, and that methoxy will be substituted over there. Sorry, here positive charge will be there. The positive charge will be attached with the lone pair of electrons of oxygen, so that methoxy group will be substituted on benzene, which is called anisole, right? This is the way final product will be obtained, but the key intermediate which driving the entire mechanism will be benzene. So that part we are taking care. Benzene intermediate to achieve this final product, starting with this anthranilic acid called orthoamino benzoic acid. This is the way we can explain about question number 6. By this, we can conclude the session where we covered, we focused, we entered into various corners of chemistry, included with the organic chemistry part, IPAC nomenclature part, and physical chemistry part we covered over there, and oxidation reduction reactions are mentioned. This is the way different dimensions of chemistry got covered, and the kind of session will be very much enthusiastic towards the aspirants who are preparing, who are thirsty about the chemistry, who are searching for the various kind of problem solving analogy over there. That's the reason why I'm sincerely requesting to like the channel, comment which part is really important for you, and share with the parents who are seriously preparing for the examination. Subscribe the channel to achieve more updates over here. Thank you very much for your patient listening. Thank you one and all.